Welcome to the next video in the series of die casting. Here we're going to be looking at the different die casting processes. So what are the different types? Die casting is the process of injecting molten metal into a steel die to create a finished cast part. There are two main types of die casting process: hot chamber and cold chamber die casting. There are also variations on these two types, including low pressure die casting, vacuum die casting, squeeze die casting, and semi-solid die casting. We're going to be looking at all of these processes in this video. You can see here an example of vacuum assisted die casting with the vacuum pump at the top. We'll cover this in more detail later on. First of all, let's have a look at hot chamber die casting. So hot chamber die casting, often referred to as gooseneck casting, is by far the most widely used of the two processes. This process has the cylinder chamber of the injection mechanism fully immersed in the molten metal. This design allows the hot chamber section to fill with molten metal. The plunger then forces the metal into the die through the gooseneck port. After the casting has solidified, the die opens, the casting removed, the die closes. During this time, the plunger retracts and the cycle starts over. This is a continuous casting process. This process is most suited for metals with lower melting points such as lead, magnesium, zinc, and copper. The diagram on the right clearly shows the gooseneck shape. You can also see the cylinder chamber fully immersed in the molten metal here. Let's have a look at cold chamber die casting. So cold chamber die casting is more suited to metals with higher melting temperatures such as aluminum. The metal is heated in a furnace and the molten metal is ladled directly into the shot chamber, ready for injection. You can see that here in this image. The plunger then forces the molten metal into the die cavity. The force is maintained to ensure the cavity is completely filled during solidification. The die is then opened and the casting removed. During this time, the plunger moves back, ready for the next cycle. So let's have a look at the difference between cold chamber versus hot chamber die casting. The main difference between cold chamber die casting and hot chamber die casting is that the cold chamber process, the molten metal is ladled into the shot chamber from an external source. The hot chamber process, the molten metal source is attached to the machine. The hot chamber process has a shorter cycle time due to the molten metal constantly and automatically filling the shot chamber. This makes the manufacturing process a quicker output than the cold chamber die casting. Cold chamber die casting requires greater injection pressure than the hot chamber process. You can see here in this diagram a layout of a cold chamber die casting. Let's have a quick overview of low pressure die casting. Low pressure, or simply pressure die casting, uses air pressure to force molten metal through the runner system and into the die cavity. The die is positioned above the molten metal. The refractory tube links the die gate to the molten metal. Air pressure is applied to the airtight chamber. This forces the molten metal up through the refractory tube and into the die. Typically used in steel castings such as railway carriage wheels. You can see the layout of a low pressure die casting process here. Vacuum die casting. Vacuum die casting, or more accurately described as vacuum assist die casting, is used when high integrity castings are required with close to zero gas voids. The die cavities must be machined very accurately and the system must be airtight in order to form a vacuum seal. The process requires accurate real-time control over the vacuum pressure, molten metal flow speed, and injection pressure. An injection cycle involves the gases in the die being exhausted out via a vacuum valve. The molten metal is injected into the die. The vacuum pressure pulls the molten metal into the die, which creates a highly integral casting with superior properties. We quickly saw this diagram at the beginning, but here it is again so we can have a look at how the vacuum assist layout works. Squeeze die casting. Molten metal is poured into the bottom half of a preheated open die. As the metal starts to solidify, the top half of the die comes down under pressure and is held in place until the metal solidifies. The casting is then ejected from the die. As a runner and feed system are not required for this process, metal yield are generally very high. Production rates are not high due to the slow cycle time, generally around 15 to 30 shots per hour, depending on the size and complexity of your product. Typical products produced are aluminum wheels, hubs, and other automotive parts. We can see the squeeze die casting layout here. SemiSolid Die Casting. Semi-solid metal casting, or SSM, is carried out with the metal between its liquidus and solidus state, ideally where the metal is 30% to 65% solid. The semi-solid billet is loaded into the shot sleeve of the die cast machine and injected into the die. This process can produce near-net castings. Castings are normally high integrity with minimal gas voids or porosity, typically used for high casting of aluminum, copper and magnesium, such as engine suspension mounts, engine blocks and oil pump filter housings. We can see the process over here on the right hand side. We can see the raw material is cut into slugs. That is then induction heated, transferred to the shot sleeve, injected into the die where the complete component is ejected. Please check out our other videos in this series, and you can contact us if you need any help with your projects in China. For your convenience, there's a link to contact us below. Oh, and don't forget to like, share, and subscribe to our channel. And you see this little bell symbol? That's important to hit that, because that will give you a notification each time we upload new content. So thanks for listening. My name is Paul Adams from Sofeast, and I shall see you in the next video.